A 1.5K resistor and a coil with a 2.2K inductive reactance are in series across an 18V AC source. The power factor is A 564, B 0.564, C 6.76, D 55.7. The correct answer is 0.564. The voltages in problem 5 are measured at a certain frequency. To make the resistor voltage less than the inductor voltage, the frequency is A increased, B decreased, C doubled, D not a factor. The correct answer is increased. In a series RL circuit, 12V RMS is measured across the resistor and 14V RMS is measured across the inductor. The peak value of the source voltage is A 18.4V, B 26.0V, C 2V, D 20V. The correct answer is 26.0V. To increase the current in a series RL circuit, the frequency A should be increased, B should be decreased, C should be constant, D cannot be determined without values. The correct answer is should be decreased. A 470 resistor and a coil with 125 inductive reactance are in parallel. Both components are across a 15V AC voltage source. Current through the inductor is A 152 mA, B 32 mA, C 12 mA, D 120 mA. The correct answer is 120 mA. A 1.2K resistor is in series with a 15 mAh coil across a 10 kHz AC source. The magnitude of the total impedance is A 152.6, B 1526, C 1200, D 942. The correct answer is 1526. When the frequency is decreased, the impedance of a parallel RL circuit A increases, B decreases, C remains constant, D is not a factor. The correct answer is decreases. A 470 resistor and a 200 mAh coil are in parallel. Both components are across a 1.5 kHz AC source. The total admittance of the circuit in polar form is A 12.6076 ms, B 12.1876 ms, C 218.76 ms, D 12.1876 ms. The correct answer is 12.1876 ms. Referring to problem 23, the reactive power is A 10 mVAr, B 100 mVAr, C 6.76 mVAr, D 148 mVAr. The correct answer is 100 mVAr. A 12K resistor is in series with a 90 mAh coil across an 8 kHz AC source. Current flow in the circuit expressed in polar form is I 0.30 mA. The source voltage expressed in polar form is A 3.84 20.6 V, B 12.8 20.6 V, C 0.3 20.6 V, D 13.84 69.4 V. The correct answer is 3.84 20.6 V. A 140 resistor is in parallel with an inductor having 60 inductive reactance. Both components are across a 12V AC source. The magnitude of the total impedance is A 5.51, B 55.15, C 90, D 200. The correct answer is 55.15. When the frequency of the voltage applied to a series RL circuit is decreased, the impedance A decreases, B increases. C does not change. D cannot be determined without values. The correct answer is decreases. In a parallel RL circuit there are 3 ARMS in the resistive branch and 3 ARMS in the inductive branch. The total RMS current is A6A, B 424 mA, C 4.24A, D 42.4A. The correct answer is 4.24A. A 47 resistor is in series with an inductive reactance of 120 across an AC source. The impedance expressed in polar form is A 47 68.6, B 120 68.6, C 129 31.4, D 129 68.6. The correct answer is 129 68.6. When the resistor voltage in a series RL circuit becomes less than the inductor voltage, the phase angle A increases, B decreases, C is not affected, D cannot be determined. The correct answer is increases. Which of the following power factors results in less energy loss in an RL circuit? A1, B 0.8, C 0.4, D 0.2. The correct answer is 0.2. A 3.3K resistor and a 120 mAh coil are in parallel. Both components are across a 2 kHz 12V AC source. The total current in the circuit is A 8.74 mA, B 874 mA, C 874A, D 8.74A. The correct answer is 8.74 mA. When the frequency of the voltage applied to a series RL circuit is increased, the phase angle A decreases, B increases, C does not change, D cannot be determined without values. The correct answer is increases. If a load is purely inductive and the reactive power is 12 W, the apparent power is A0 W, B12 W, C6 W, D24 W. The correct answer is 12 W. If the frequency is halved and the resistance is doubled, the impedance of a series RL circuit A doubles, B halves, C remains constant, D cannot be determined without values. The correct answer is cannot be determined without values. As frequency increases, A both series and parallel RL impedance decrease, B series RL impedance decreases and parallel RL impedance increases, C series RL impedance increases and parallel RL impedance decreases, D both series and parallel RL impedance increase. The correct answer is both series and parallel RL impedance increase. What is the true power of a 24V parallel RL circuit when R45 and XL 1100? A 313.45 watts, B 12.8 watts, C 44.96 watts, D 22.3 watts. The correct answer is 12.8 watts. If XL 100 and R 100, then impedance will be A 141.4, B 14.14, C 100, D 200. The correct answer is 141.4. What is the magnitude of the phase angle of a 24V parallel RL circuit when R45 and XL 1100? A 0.001, B 2.3, C 87.6, D 89.9. The correct answer is 2.3. What is the magnitude of the phase angle between the source voltage and current when a 100 mAh inductor with an inductive reactance of 6K and a 1K resistor are in series with a source? A 0.1, B 9.0, C 61.0, D 81.0. The correct answer is 81.0. Which of the following statements is true about a lag network? An increase in frequency causes an increase in phase lag. B. An increase in frequency causes an increase in the magnitude of the output voltage. C. A decrease in frequency causes an increase in phase lag. D. A decrease in frequency causes a decrease in the magnitude of the output voltage. The correct answer is an increase in frequency causes an increase in phase lag.